So I'm gonna put this kind of in the corner. So your test will be, have questions similar to what we're going over today, from units 1 and 2. If we look at this Pareto chart, um, what conclusion can we make? So basically, there's lots of options. You can say the least amount of people um, almost hit a car. You could say the more accidents happen because of people swerving um, while using their cell phone. You could even say approximately 20 accidents happen when people are using their cell phone. So, for this, there are several correct answers. It could be more people have accidents when on their phone by swerving. You could say less people almost hit a car while on their phone. You could say um, almost the same number of people cut off a car as almost hitting a car. Now, obviously, you can tell that one's more than the other, but those are just several possible answers. Now, if you watch the video about the different types of graphs, you would know that a Pareto chart is a special type of bar graph. And one of the questions on here is, how are the bars in a Pareto chart organized? Does anyone know the answer to that? How are the bars in a Pareto chart organized? Right, so greatest to least. That should say least. So yeah, greatest to least. And if you don't remember that, if you kind of look at the Pareto chart here, you see it goes from greatest to least. So now this over here, this histogram, how many classes are there in this histogram? There's 5, because it's however many bars, like not necessarily how many bars, but right here, these numbers here. Now, I say that because you could have a gap, so you could have another class that with a space in it. So, approximately, what is the greatest frequency? 40%. Now, sometimes I have people that want to say 19 and a half, but that's not frequency. Now, 19 and a half has the greatest frequency, but it says approximate the greatest frequency. Now, approximate the least frequency. So, the least frequency occurs at 21 and a half, and I personally would say that's about 2%. Now, if you had said 1%, would I be like, "Oh, nope, you're wrong." No. But you should have less than 5%, because 5% would be about halfway here. So I would say about 2%. All right. So over here, looking at this frequency distribution. So we see here we have different classes. If we wanted to know what the class width was, the class width is going to be 31 minus 20. So the class width of this would be 11. If you remember, you always subtract two consecutive um, upper upper limits. Um, or lower. These are lower limits. So it doesn't, as long as you subtract 2 consecutive. So now, in order to find the midpoint, does anyone remember what you do? So you should, to find the midpoint, you want to average the class. So you would say 20 plus 30 divided by 2. And so when you do that, you would get 25. Now, this one you would say 31 plus 41 divided by 2. And when you do that, you would get 36. For this, you would say 42 plus 52 divided by 2, 47. Then you would continue that pattern, um, and you would get your numbers, and these would be your midpoints. That is the middle of each class. So now, to find your class boundaries, so you ask yourself, well, what is between 30 and 31? 30.5. Now, before 20 would be 19.5. All right, so now here, the class boundaries, we would have 30.5, 41.5. Then it would be 41.5 to 52.5. All right, then you would have 52.5 to 63.5, 63.5 to 74.5, 74 and a half to 85 and a half, 85 and a half to 96 and a half. So that is your frequency distribution. And what those class boundaries are is that would show you where you would create your bar if you were making a histogram. So now, beside of it, it says list the actual data entries from this dot plot. So when you look at this dot plot, how many 13s are there? 2. So you would write 13 twice. You would write 14 3 times. You would write 15 1, 2, 3, 4, 5. 15 5 times. You would write 16 once, 17 twice, 18 once, and 19. And this is important because we're going to get to something in the next unit, and you have to do this. And I see a lot of times that people like they just want to write 13, 14, 15, 16, 17, 18, 19, but you have to identify that there's 2 13s, 3 14s, and so on, because if you want to find like the average, you would have to add each one of those up. Um, and so the next question, it says, what is the maximum data entry? So that means what is the highest data entry? Not the most frequent, but the maximum value. So what is, yes, 19 is your maximum. If I asked for the most frequent, you would say 15. We're not playing in the snow right now. Sorry, guys. Madeline, go. Mommy's teaching. All right. So now, looking at this histogram here, how would you describe the shape of the data? So is it uniform? Is it skewed right, skewed left? It is skewed left. The tail is to the left, so it is skewed left. And so you just always have to ask yourself, like, where is it like dragging off to? It's dragging out to the left. All right. So that is what you'll see as far as like looking at graphs and histograms uh, and types of graphs. Then we're going to have some questions um, that are mostly like from there. It's going to be vocab stuff. Like if we look at these next three and we want to identify the population and the sample. So number one says a survey of um, four a survey of 4,787 U.S. adults found that 15% use ride hailing applications. So, looking at this, I need y'all to be quiet. So, looking at this, the population is U.S. adults. So, the population we're looking at is U.S. adults, and we have a sample of 4,887 U.S. adults. So the population is the U.S. adults, and we're looking at specifically 4,787 of them. So the data set description is that this part found that 15% use ride hailing applications. So 15% use ride hailing applications. All right, the next one says a survey of 1,205 physicians found that about 60% had considered leaving the practice of medicine because they were discouraged over the state of U.S. healthcare. So the population comes from physicians, and the sample is the actual number of physicians. And so the description is discouraged over the state of U.S. healthcare, or actually, let's say that 60% considered leaving. All right. All right. So, what the sample data description means is out of the sample, what did they discover? So, 3 says 83 doctors working in St. Louis were surveyed concerning their opinions of healthcare reform. So, doctors, the population is we're looking at doctors in St. Louis, and they chose 83 doctors. What do they want to find out? Opinions on healthcare reform. It didn't give us the results, so what we want to know is the opinions on healthcare reforms. So being able to identify the population and then the sample it's really what that is doing is making sure you understand that a sample is within the population. So if I was to say I surveyed um, my statistics class at Averett University, then the population would be statistics classes at Averett University. The sample would be Miss Forney's statistics class or the 19 students in this class. All right. So for the next set, we want to determine whether the number describes a population parameter or a sample statistic. So a population parameter would be for the entire, like cover the entire population, and the sample statistic would be a portion of the population. So number 4 says, in a study of math majors at a university, 10 students minored in physics. So, in this case, in a study of math majors at a university, they looked at did they look at just a portion of math majors or did they look at all the math majors? They looked at all of them. So, they looked at all of them, but then we picked out 10 students minored in physics. Is the 10 students represent the entire population, or is it a sample statistic? Is it a portion of the population? Sample. And it's a portion. In a survey of 1,000 likely voters, 29% trusted media fact checking. So, is this a sample or the population? Sample. 50% of a sample opposed drilling for oil and gas in the Arctic Circle or in the Arctic National Wildlife Refuge. I'm just making stuff up. So that would be a sample statistic. It is a portion. All right. For problems 7 through 9, determine whether the data are qualitative or quantitative. So, with qualitative, we think of categorical, and with quantitative, what do we think of? Numerical. Now, categorical categorical is where we think qualitative. I feel like there was another word we used, but we'll stick with this. So number 7 says the ages of a sample of 350 employees. So for age, is age qualitative or quantitative? Age. Is age numbers? Yeah, so that would be quantitative. Age is numbers, so quantitative. Now, the marital statuses of all engineers. The marital status is either going to be like single, married, so forth. So, is that qualitative or quantitative? Qualitative, that's not numerical. Now, zip codes. That's kind of like a Zip codes may be numbers, but is it numerical in an ordering sense? Or are they more like labels? That would be qualitative because it is a label. So zip codes are like labels. Zip codes are labels. Now, if you think about like jersey numbers, now jersey numbers would be quantitative because you can at least order them. Now, the order doesn't mean anything as far as, I mean, order least to greatest. But for your zip codes, the purpose of your zip code is as a label. Now, the next two ask for if it's nominal, ordinal, interval, and ratio. So we're going to answer these, but then we're also going to just kind of go back over what each one means. So go back over it before. So nominal is a naming. Ordinal, it can be ordered, but it doesn't really can't calculate differences. So think about like you could order like your grades A, B, C, D, but you can't calculate the difference there. Then interval and ratio. So ratio has a natural zero, meaning zero means that you have nothing. So if you think about like the number you got correct on a test, and if you, that would be ratio. Your actual like the money in your bank account could be ratio. Um, Interval, the my best one that I can think of for interval is like the temperature, because when it's 0 degrees, that doesn't mean there is no temperature. So interval, you can calculate difference, but there's no natural zero. All right. So this first one says the four departments of a printing company. So administration, sales, production, and billing. Would that be nominal, ordinal, interval, or ratio? Nominal. It's just the names, the categories. Nominal. Now, this next one says the total compensation of people. This is their salaries. So, if the money you make is what? Your in your income would be ratio, because if they had zero, that meant they were probably fired. But I mean, obviously, if I'm working, I expect money. So ratio. All right. Determine whether we have discrete or continuous. So if you remember, discrete is countable, continuous is not countable. So discrete is countable, and continuous is infinite, not, or I'm just putting not countable. And I'm so sorry, countable. My pen is just really not working, and I need to order a new one off. Like I ordered it from Amazon, but I guess because of the weather, things that I've been ordering have not been like delivering. So I don't know. I don't really want to order it until I know that it can be delivered. All right. So the number of days where the temperature rose above freezing. So how appropriate. So can we count the number of days? Yeah, so that is discrete. Now, number 10 says sample data that indicates the mean weight of cars at a junkyard. So, when we're looking at the mean weight, you don't really count that. That's calculated. So, when we're looking at the mean, that would be continuous because it's not, you don't count the mean. You would have to compute. All right. In a survey of adults, it is found that 39% of them have guns in their home. Can you count the number of people? Can you count like the number of yeses and the number of nos? Yes, so that would be discrete. Okay. So when gas masks from branches of the U.S. military were tested, it was found that 10,322 were defective. So, if you have the masks, can you count the actual number of defective versus not? Yeah, so that would be discrete. Now, I mean, you probably don't want to count all of them, but you can. All right, the number of items produced per hour at a local manufacturing company. Can you count the number of items that were produced in an hour? Yeah, sorry. I don't know if y'all can hear my daughter, but she's here. The average height of all freshmen entering college is 68.4. So that would be continuous because, again, we're looking at an average. And to be fair, for 13, I would take discrete or continuous because if we're looking at number of items produced per hour, not in an hour, it could be you might be looking at this as an average as well. So I would take for a question like number 13, I'd probably take either because it depends on how you interpret it because it doesn't come it says per hour. So looking at that per hour, that might would be taken as an average per hour, not like looking at what you actually count in an hour. So for 13, I would take either because depends on interpretation. Depends on interpretation. I usually don't give questions that can be done like that when I'm done teaching. Okay. All right. I'm over halfway. Okay. Sorry again. Determine whether the given description corresponds to an observational study or an experiment. So, what do we know? An experiment has to have what? So, yeah, you have to be doing something to it, like to make a change. So, with that being said, also, if you're on campus, make sure you move your car out of the commons parking lot by noon, just in case you didn't see that. Anyway, yeah, it has to be have a modification. Observation is something that you can either just watch or ask and get your data that way. So it says patients are given Lipitor to determine whether this drug has effect on lowering high levels of cholesterol. So we are giving people something to see if it works. So that would be an experiment because we modify